Okay, on to course content. We're going to talk about expressions. An expression describes a computation and evaluates to a value. Now, expressions are not something particular to computer science. Mathematicians have been describing how to compose different numbers together for a long time. They invented lots of different ways of describing computations using expressions. In order to add two numbers together, you express that by adding this plus sign in between two numbers. Division is completely different. You put one number over the other. In order to express a square root, you put a number in a little house. To take the sine of an angle, you write sin, not sine. Sine takes too long to write, just sin. And there are all these other ways of expressing how to combine together different values. It turns out that one of these is a generalization over all of the others, and it's all we need. And that's function call notation, f of x, or f of x comma y, etc. So as computer scientists, instead of expressing computation using all of these different forms with the subscripts and the superscripts and the vertical bars, we'll just write down everything using function call notation. Okay, so here's my claim, is that all expressions can use function call notation. And for that, I'll just fire up Python and show you. I start Python by typing Python 3, which gives me a very recent version of the programming language interpreter. Now, an interpreter provides a prompt where it waits for me to type an expression and then displays its value. So the expression that I type here, 2000 plus 15, now includes two different values combined together by addition. And the value that's displayed is what I get by adding these two numbers together. And Python is quite a powerful calculator. I can multiply multiple numbers together. I can even nest things with parentheses. I can divide. There's special notation for raising something to the third power. If I want to add stuff together at the end, it's just going to compute that for me very quickly. This is an expression. This is its value. Okay, what about call expressions? Well, call expressions have a special form where you name a function that you want to call, in this case the max function, and then you write down expressions that give you the values to which max will be applied. What's the max of 2 and 4? It's 4. What's the min of -2 and 50,000? 500? 50,000. Let's not get crazy. Okay, so -2. So these are called call expressions. When you see some function and then some parentheses, and you see these other expressions separated by commas, that is a call expression. Now, I claimed that everything could be expressed using a call expression. That's including multiplication and division and addition, etc. So in addition to the plus, which is used between two expressions to add them together, there's also a function called add. Now, it's not available all the time. I have to write this import statement in order to get access to add and mul. That's only a minor inconvenience. I just do it once, and now I can add together 2 and 3 using a call expression. I can multiply together 2 and 3 in order to get 6. Now, call expressions are really wonderful things. For instance, they can combine multiple values together just by using lots of commas. What's the max of 1, 2, 3, 4, and 5? Well, that's 5. They can also be nested within one another. I can multiply the result of adding 2 to the result of multiplying 4 and 6. Okay, I've added 2 to what I get by multiplying 4 and 6, but I said I was going to multiply that by something. Well, how about the result of adding 3 and 5? And that gives me 208. Now, in call expressions, you don't need to memorize the order of operations. Just the nesting structure of the expression itself tells you exactly what gets multiplied before it gets added. So you have to multiply 4 and 6 in order to add it to 2. Life is not so simple when you use these infix operators between different values, because you have to know that multiplication comes before addition in order to understand how the expression gets evaluated. So we're very pro call expression in this course. We want to understand exactly how it works. So first, let's talk about the structure or anatomy of a call expression. There are always parentheses. The whole thing is a call expression, which has within it other expressions. Everything that comes before the opening parenthesis is called the operator sub-expression. And by sub-expression, I just mean it's an expression within an expression. The operands are separated by commas within parentheses. Operators and operands are also expressions. Now these are very simple expressions. The number 2, the number 3, or the name add. They evaluate to values. The number 2, the number 3, the function that adds two numbers together. The way in which call expressions are evaluated is always the same. It's an evaluation procedure. Now, the way that programming languages work is that they interpret your expressions by applying evaluation procedures. And they just apply those same procedures over and over again, procedurally. The one for call expressions goes like this. You evaluate the operator and then the operand sub-expressions in that order. Then you get a function from the operator and arguments from the operands. You apply the function that is the value of the operator to the arguments that are the values of the operands. So first you evaluate all the sub-expressions, and then you apply a function. All that in order to add 2 and 3 together. Well, the reason why we go through this in such detail is to observe that the same evaluation procedure can be used many times over in order to evaluate much more complicated nested expressions. So here's that nested call expression that we tried before in the interpreter. Now, Python just said 208. Like magic, it had evaluated the whole thing. Well, how did it do it? It just applied that evaluation procedure. It said, oh, this is a call expression. I see parentheses. Therefore, I must evaluate the operator. That's the function that multiplies. I must evaluate the first operand, which is another call expression, and so it applies the same procedure again. The same procedure says, I'm going to evaluate the operator, that's the add function. I'm going to evaluate the operand 2, which is just the number 2. Then I'll evaluate mul46, which is another call expression. Fortunately, I have a procedure for evaluating call expressions. It goes like this. I evaluate the operator and operand sub-expressions to get the function that multiplies the number 4 and the number 6. Since I now have all of the operands evaluated, I can apply multiply to 4 and 6 to get 24. This is the value of that expression. Now I've actually evaluated all of the operands from this sub-expression, which means I can apply the function add to 2 and 4 in order to get 26. So far, I've evaluated one operand. I've evaluated the operator, but I still need to evaluate the last operand before I get to multiply anything. That means I have to figure out what add 3, 5 is. That's another call expression. I find the operand and operators, evaluate to the add function, 3 and 5. Adding 3 and 5 gives me 8. Multiplying 26 times 8 gives me 208. This diagram is called an expression tree. It's an illustration of everything that happens within the computer as it evaluates this nested call expression. So the important thing to observe here is that the order in which the expression is evaluated provides the right information at the right time. You have to have figured out that this thing is equal to 26 before, and this thing's equal to 8 before you know what to multiply together in order to finish the computation. It's also just an illustration of the same process being applied over and over again, the procedure for evaluating call expressions. So this whole thing is an expression tree. That's called an operand subexpression. This is the value of that very subexpression. So I just copied this thing down here, and then I went through the procedure to compute its value 26. This is also the first argument to mul. An argument is always a value, and this value 26 is multiplied by 8 to give me 208, the value of the whole expression.